Assalamu alaikum wa rahmatullah. Hi everyone. In this video I will be working on question 18 from the coverage of a grade 12 elite. This question is about unit 7. We are given a differential equation, and in the first part we need to sketch the slope field at these selected points. We are given 9 points. We need to sketch a slope field for the given differential equation. So first of all, let's rewrite the differential equation. dy over dx equals y minus 1 all squared times cos of pi x. Please make sure your calculator is in radian here, because we're dealing with pi, okay? Now, to sketch the slope field, you have to make a table of values, x and y and dy over dx, check the value and the sign of the derivative, which is the slope, and then you can sketch the slope field. So I'm going to create a table. Here I'm going to select x, y, and then I will be finding dy over dx. So we have 9 points, so we have to test these 9 points. Starting from the first row, I'm talking about the first point in the first row here. X is minus 1 and y is 1. You plug in these numbers, x and y, into dy over dx, you are going to get 0 for the derivative, which is the slope of the tangent line. So at this point we have a horizontal line segment, which means the slope of the tangent line at this point is 0. Now, continue doing this for the first row, where the second point has 0 and 1, the third point has 1 and 1. Substitute those numbers into dy over dx, you're going to get 0 and 0. So here it's also a horizontal line segment, here it's also a horizontal line segment. Okay, so let's continue doing it for the second row. We have negative 1 and 0. We have 0 and 0, and also 1 and 0. Substitute those values into the differential equation. You are going to get for the first one negative 1, and then 1, and then negative 1. So the slope of the tangent line at the point negative 1 and 0 is equal to minus 1. So it should be decreasing, right? And at 0 and 0, the slope is 1. And at 1 and 0, it's also negative 1. So make sure it's parallel to the first one. I'm talking about the one at the point negative 1 and 0. So make sure they are parallel. This one here and this one here, they share the same slope, so they must be parallel. Now, the last row, where we have negative 1 and negative 1, we also have 0 and negative 1 and 1 and negative 1. So let's check the value of the derivative at those points. So we are getting negative 4 and then 4 and then negative 4. So negative 4 means the segments should be decreasing, but steeper than the one on negative 1 and 0. So make sure this line segment is steeper, okay, steeper than the one on top of it, okay, and it's parallel to the one at 1 and minus 1, which is here. So make sure these two also are parallel. And also we have at 0 and minus 1, the slope is 4, so it's increasing, but it's steeper than the one at the origin. So it's steeper than the one at the origin. So this is how we do the slope field. Now, part B says there is a horizontal line with equation y equals c that satisfies this differential equation. Find the value of c. That's pretty much easy, because if you look back at the slope field, you can see that there is a particular solution that is a horizontal line, right? So there is a horizontal line at y equals 1. So here, this is a particular solution for the given differential equation with this equation, y equals 1. And if you look at part B, it says y equals c. That means c equals 1. This is part B. Okay, now for the third part, which is part C, it says find the particular solution to the differential equation with initial condition 1 and 0. So we have to find the general solution. We will use the initial condition to find the value of C, and then we will find the particular solution. So let's look back at the differential equation. We have dy over dx equals y minus 1 all squared times cos of pi x. We need to find the particular solution for this differential equation. Okay, finding the particular solution is done using a method called separation of variables. Separation of variables means keep all the x's and dx's on one side and all the y's and dy's on the other side. How can we do that? We can do that simply by multiplying both sides by dx. Okay, this is very clear. We can multiply here by dx and here by dx. And also we can divide by y minus 1 all squared. Y minus 1 all squared. Y minus 1 all squared. Now what's going to happen if we do this? We can cancel y minus 1 all squared, y minus 1 all squared. We can also cancel dx with dx. Notice that all the y's on the left hand side and all the x's on the right hand side. Now, we have 1 over y minus 1 all squared dy, and here we have cos of pi x dx. After separation, after separating the variables, now you can integrate both sides. You can integrate both sides. We are looking for the particular solution, so we need to integrate. Okay, now in both sides we have to use u substitution. Okay, we have to use u substitution. Okay, the answer key doesn't refer to the u substitution. They are doing it directly, but it's done using u substitution. So let's try to do it here quickly. For the first, for the left hand side, I'm assuming that u equals y minus 1, yani du equals dy. This is for the left hand side. Now for the right hand side, I'm going to assume that w equals cos of pi x, and dw will be negative pi sine of pi x dx, right? Or we can just assume the inner. Sorry, I just did a mistake here. Okay. We can assume only the inner to be w, which is pi x. That means dw equals pi dx. Okay? Now, we can divide by pi on both sides. So dx equals dw over pi. Okay, now let's substitute them back here. So we have the integral of 1 over u squared du, right, equals the integral of cos of w times dw over pi. What's going to happen next? We can rewrite the first one, the left hand side, we can get this one on top. So we will have the integral of u to the power of minus 2 du equals 1 over pi times the integral of cos of w dw. We can now apply the power rule on the left hand side, which is given u to the power of minus 1 over minus 1 equals 1 over pi times sine of w plus c. Now we can get this one down because the power is negative. So we have negative 1 over u, and u is y minus 1 equals 1 over pi times sine of what? Sine of w. W equals what? W equals pi x plus c. This is the next step after doing the integral. Now we need to use the given initial point to find the value of c. The initial condition, if you look back at part C, it says f of 1 equals 0. F of 1 equals 0. That means we can use 1 and 0 to find the value of c. So if you substitute x equals 1 and y equals 0, you can find the value of c. So we have negative 1 over 0 minus 1 on the left side equals 1 over pi sine of pi times 1 plus c. So the left side is equal to 1. Now sine of pi is 0. That means 0 plus c. That means c equals 1. We found c. We can put it back here, right? So we have negative 1 over y minus 1 equals 1 over pi sine of pi x, right, plus 1. Now I want to multiply everything by pi in order to get rid of this here. So let's multiply both sides by what? Pi. So let's multiply everything by pi. So this is multiplied here and also with the 1. So negative pi over y minus 1 equals, now pi with 1 over pi, it will get cancelled. We have sine of pi x plus pi. Okay? Now, we can put a denominator of 1 here, and then we can flip both sides. That means, let me give myself a little bit of a space here. y minus 1 over negative pi, right, equals 1 over sine of pi x plus pi. We can multiply both sides by negative pi, right? Let's multiply here by negative pi and here by negative pi. So this is cancelled with this one. So y minus 1 equals negative pi over sine of pi x plus pi. The last step is to move the 1 to the other side, or move the negative 1 to the other side, or add 1 to both sides. Okay, just get this to the other side. So y is equal to 1 minus pi over sine of pi x plus pi. That is the final answer. This is the particular solution that passes through 1 and 0. Y equals 1 minus pi over sine of pi x plus pi. I know that was quite long, but you need to practice a lot in order to be able to manage your time in the exam. So, good luck.